Hello, I am Dr. Vijay Vandari. So I am going to teach you today introduction of machine learning. So let's start it. So now I will tell you about a brief history of machine learning. Okay, so the term machine learning was introduced by Arthur Samuel in 1959, an American pioneer in the field of computer gaming and artificial intelligence, and stated that it gives computers the ability to learn without being explicitly programmed. And in 1997, Tom Mitchell gave a well-posed mathematical and relational definition that a computer program is set to learn from experience with respect to some task and some performance measures. If its performance on T as measured by the P, so it is improves with experience E. So machine learning is the latest buzzword floating around and deserves to, as it is one of the most interesting subfield of computer science. So now question is arise, what does machine learning really mean? So let's try to understand machine learning in the terms of. After this, we will try to understand one example. Consider if we toss a paper to a dustbin. So let's try with an example. After first attempt, we will realize that we will have too much force in it. After second attempt, we will realize if we are closer to target, but we need to increase our throw angle. And what is happening here is basically after every throw we are learning something that improving the end results. So we are programmed to learn from our experience. This implies that the task in which machine learning is concerned offers a fundamentally operational definitions rather than defining the field in cognitive terms. This follows Alan Turing's proposal, computing machinery and intelligence. So he asked the question sometimes, can machine things? So it is replaced with the questions, can machine do what we can do? Now the answer is within the field of data analytics. Machine learning is used to devise complex models and algorithms that lend themselves to predictions. In commercial use, we talk about it is known as predictive analytics. These analytical models allows researchers, data scientists, engineers, and analysts to produce reliable, repeatable decisions or results, uncover the hidden insights through learning from historical relationships and trends in the data sets like input. Now we will cover application of machine learning and key elements of machine learning. So here we can see the traditional programming, the data we are giving the input to the computer and program as well, and it is producing output. But in machine learning, data and output is given to the computer model and it produces programs accordingly to it. So the big question arises here. In traditional program, we giving the data and program both, but in machine learning, data and output, and accordingly to it we design a program. Now we will talk about of application of machine learning. I hope so you are understanding it. If any questions, so we can ask me after completion of this lecture. So many of the applications of the machine learning is that research, computational, biological, financial, e-commercial, space explorations, robotics, information extractions, social networks, and debugging. Because if we talk about the computational biological, so it is a rational design trucks in the computer based on the past experiments, as well as it also using debugging using computer science problems like debugging labor intensive process could suggest where the bug could be. Now there are three key elements of machine learning. First is representations, evaluations, and optimizations. So how to present the knowledge, and we can take an example of decision trees, sets of rules, instances. Now we evaluate the candidate program's hypothesis We can take an example of include accuracy, predictions, and recall, squared errors, like we have covered in the first lecture of regression, likelihood, probabilities, cost margins, entropy, and then we can optimize the way candidate programs are generated, known as the search process. And we can take an example of combinatorial optimization, convex optimization, constraint optimization. Thank you so much for today, and if you have any queries, so please ask me. Thank you.